Well, it's great to see so many people here in the crowd today. I'm hoping that at the end of this conference, you're all going to be so excited about data science and the prospects of deep learning, machine learning, and artificial intelligence that you go back, talk to your colleagues, talk to your family members, talk to your neighbors, talk to the people at the grocery store. We need a lot more people doing data science and machine learning. And we'll touch on that in a little bit, but one question that I keep getting is, well, one question we'll talk about, and that's, is this an AI winter coming, or is it AI spring or AI summer? But what I want to emphasize is that we're at the first mile of a very long marathon in artificial intelligence. People start pointing out who are the winners and the losers. And at this point, there are no losers, unless you're not jumping into data science and machine learning and AI right now. Because we're really at mile 1, and it's a marathon, it's not a sprint. We've got a long way to go. Teams, companies will be passing each other the baton of AI as different people innovate and out-innovate each other. So when you think about artificial intelligence, the thing that oftentimes comes to mind with people is deep learning. And I want you to know, anytime somebody says deep learning, they 100% mean training of artificial neural networks. And when we talk about the neural networks that we're training right now, they're incredibly simple compared to the human brain. The neural networks that we're training now, 25 million neurons, in quote, about 100 million connections, and that's far, far less than the human brain. So if people start questioning AI where we are now, I don't take that seriously. Obviously, the systems that we're building now are incredibly simple compared to where we're going. And it's not just about neural networks that are defining the emergence of artificial intelligence. It's really about this emergent property that arises from complicated systems. So the intelligence that we see is about multiple systems coming together, neural networks, machine learning, traditional databases, file systems, local file storage, graph databases, but it's about all these multiple pieces coming together, and that's where the challenge is right now in AI. The challenge is defining these system interactions and defining system architectures. And we'll touch on that a little bit more as we go along. So obviously machine learning is everywhere. So I won't really go into the details about all the ways that machine learning is being applied, other than to say that obviously it's touching things that you're doing every day, if not nearly every minute of every day. But if we talk about now, if we talk about where we are now, we're coming out of an AI winter. So those of you that might not know the history of AI, it goes back to the 50s, but the most recent real boom in AI was in the 70s to around 1985. And there was a lot of research, investment, a lot of hype around AI, and ultimately it collapsed in 1985, and we've been experiencing this AI winter. An AI winter that has started to thaw sometime around 1995, 96, and leading to where I think we are right now, and that's this AI spring. So we're just planting seeds, we're building roots, we're building the foundation for an AI summer that's coming. So let's just go back to that, the beginning of the thawing of AI. It really starts around 1997, 1998. In 97, IBM built Deep Blue, and we beat Garry Kasparov at chess. Now, it was more significant amounts of computation, but it was still the point where a machine beat a human, which is a critical milestone. LINET 5 came out in 1998. And that was one of the first systems that started to fully automate tasks that humans were doing. So it's the point that banks started using artificial intelligence, started using machine character recognition to process checks, where the Postal Service could start processing envelopes automatically using machine intelligence. And between 1998 and 2011, things were slow going. Really what you'll see here is this type of exponential change in capabilities. So I won't go into the 10-year period there, but in 2011, IBM won at Jeopardy with Jeopardy Watson. And shortly after that, also around 2011, Apple announced Siri as an extension to their iOS operating system, voice recognition. But I think what's interesting is, very powerful technique in machine learning. This concept of word-to-vec or embeddings didn't even exist at the time that IBM was building Jeopardy Watson. And if we admit what we did with Jeopardy Watson, we didn't even have much deep learning. There were no neural networks in Jeopardy Watson, yet we were able to build a solution that was powerful enough to beat a human. In 2014, some dramatic breakthroughs appeared in machine vision, and that allowed Facebook to release their face recognition capability that we're all familiar with and that so many privacy advocates are worried about. That Facebook can now recognize photos of you, your friends, your family, and you could start knowing who was in the photos that you were taking. What's interesting, though, is that the first version of Siri that came out kind of sucked. And the reason it did, or at least the reason that you saw this dramatic improvement in 2016, was that was the first time that Siri actually used deep learning. And it was a dramatic improvement. If you go to some changes that have happened recently, you now have MobileNet for single-shot detection. Many of you probably haven't seen this as much, but Google showed this on their Android phones. The ability, if I had my phone here, to kind of wave it across the audience, and it would be able to detect individuals within the theater and outline the shapes of the individuals. You could do this with cars. A lot of this, maybe not the MobileNet capability, but the object localization capability is something that we're now seeing in autonomous vehicles. And, AlphaGo. So the introduction of reinforcement learning, the introduction of computers playing computers and learning how to play a game, complicated game like Go, from scratch, and then be able to beat the best human players. So I can't go through everything that's been going on in AI, but this statistic is an interesting one. And that's that by 2020, artificial intelligence is going to create more jobs than it eliminates. And we'll talk about that elimination side. So the expectation is that we'll be creating 2.3 million jobs by 2020 and eliminating 1.8 million jobs. I don't like the idea of eliminating. The way I tend to think about it is that you're simplifying tasks so that computers can do it and humans can focus on tasks that are more meaningful and productive and where they can contribute better to society. And I think there are, if you look at, the introduction of automobiles by Henry Ford, there were no more stable boys, there were fewer barns, fewer people growing hay, put the blacksmiths out of business. But we empowered people. We allowed people to travel further, go farther, allowed the growth of cities, good or bad. But there's always a good side to the elimination of some jobs, or at least the transfer of skills to other jobs. And what we're doing right now is, like I said, this is the AI spring. This is the point where we're planting seeds. This is the point where corporations are going from spending $12 billion to $58 billion by 2021, according to IDC. AI funding last year was significant. If you look at the United States, just the United States budget for AI is about $1.2 billion. China is surpassing the US with $2 billion. And I apologize, I looked really hard and I could not find statistics for the EU and Poland. But I know that every country and group of countries is making significant investments in AI. And then, $12 billion in venture capital has been flowing into AI, and that's just investments only in 2017. So over the past several years, been well over $50 billion that have flown into investments in startup companies. Now, corporations, I was saying, are spending, $60 billion on AI by 2021, but that investment is going into these corporate pilots and implementation of AI. So doubling in 2018, doubling again in 2020. And this gets back to the request that I made at the beginning. We really need to get the word out and get more people into these AI jobs. To upskill everybody around machine learning, deep learning, data science. Because right now, what's slowing progress in AI is not that we don't have many of the tools, or we don't have some of the technologies. Definitely some of the technologies are increasing, but the biggest problem we have right now are too few practitioners. There are too few people that I can go out and find to build some of these products. Fortunately, Coursera and Udacity are making great inroads into educating and cross-educating people, application developers becoming data scientists. What my team works on is this central section, and that's that the tools available are young, they are evolving, but they're still incredibly difficult to use. We're nowhere near the maturity of what's being discussed in Sphere or Sphere. I'm super excited to get to the point where AI is as mature as these other conferences. So hopefully we have an AI sphere that I can come back to in 5 or so years and give an update. And the last thing, we need to do more with less data. And I'll talk about that and this concept of transfer learning in a few. But really where we are right now is, some people call it software 2.0. I think about it as app development 2.0, in that you fundamentally have to rethink the way we're developing applications. Instead of solving problems with user interfaces and networking and code and databases, we're now having to rethink by bringing in new tools of machine learning and how do we capture data and cleanse data and reuse that data. Algorithm development is moving fast, but it also comes down to team. And we'll talk about this a little bit later, but we are in the process of building entirely new teams within corporations. Bringing in new skill sets. We're having to build out best practices for doing artificial intelligence. And all these things are slowing down the progress that we will be seeing. But if you think about a few of the team members, and we'll talk about a couple others that I see as key team members that we need to educate and bring in. You've got the domain expert, somebody that has knowledge about the data, somebody that's a little more focused on the business side, data scientists, data engineers, and of course the application developers. But all these team members need to be able to work together because we need to build complicated architectures and software solutions, and I'll show a couple of those architectures and we'll discuss why they're so challenging. But the other thing we need to do when it comes to AI is look deeper into this concept of transfer learning. So, this is a data community here. When you think about where we're accelerating the fastest with AI, it's around using open community data sets, open source neural networks, and training these generic models that solve generic problems, but lack domain data. Bringing in your data and making this concept of a domain-adapted model. So I know some of the other talks are going to be talking about this concept. So if you haven't heard of transfer learning, generic models and domain-adapted models, there are some talks later today that are going to go into that topic. So aside from the other four team members, this is a critical team member that we're seeing corporations bringing in. And it's what's called an AI or a data value engineer. Somebody who has the ability to understand both artificial intelligence as well as the business side. So if there are any of you out there that have a business background, build out those data science skills, build out the technical skills, and think about a position as an AI or a data value engineer. Similarly, if you're on the engineering side, but you lack business or domain expertise, go on and get that expertise. Because if you're building solutions like what you see here with Apple with Face ID, or some of the things that we're seeing people do with TensorFlow Lite, we're not operating as these kind of single soldiers going out and solving problems independently. We're solving problems as a team, and the problem with solving problems as a team is understanding the whole picture of how AI is applied within a corporation. So how do you take an idea like Face ID, where, and this is, I think, one of the fascinating things about modern AI hardware, or modern AI, is that, so prior to iPhone 10, there were only two compute processors in your phone. You had a CPU and you had a GPU. What Apple did was that they introduced the concept of a bionic chip, of a machine learning chip, of an additional chip in your phone that is designed specifically for for training machine learning models and doing inferencing for those machine learning models. But for them to now enact that vision, they had to build the hardware, they had to integrate it onto the device, they had to deal with power management issues, they had to deal with new types of sensors, they had to build out the software. A whole amount of effort within the company had to get coordinated to add this type of AI-powered solution to devices. And a lot of that falls on the shoulders of the AI value engineers. Somebody that can have a big vision, understand how it functions technically, but also be able to explain in solid business terms how this needs to get built out across a company, and then leading those efforts. So the idea of an AI value engineer is somebody who is good at communicating. So they're good storytellers. They're people that understand the business needs of the business units, and yet they also understand how to communicate technical terms in simple business logic. The other thing that we need are AI architects. So the reason is that a big problem that we're seeing in bigger corporations that IBM's working with is this inability to understand the complexity of cognitive or AI systems. And we don't have enough people with system engineering skills, plus data skills, plus programming skills, plus some business skills, but people that are able to build not necessarily something as complicated as this, but this is what Jeopardy Watson looked like. So I oftentimes deal with companies that come and they have an idea and they're struggling to enact their vision, their AI vision, and the reason is they're thinking too small. They've got one problem and they're trying to solve it with one neural network, or they have a problem that requires multiple technologies and they're trying to solve it only with some machine learning algorithm. What we need to do is be able to step back and look at all the pieces that can come in. I was saying earlier, just because we're doing AI doesn't mean everything has to be built with a neural network. Traditional file systems are important. Databases, SQL databases, NoSQL databases. All these come together to produce solutions like Jeopardy Watson. There were 42 subsystems, and of course it ran on $3 million worth of hardware, but the team took 4 years and 15 people, and all the people having different skills coming together and developing a solution like this. If you look at DeepMind and what they created with AlphaGo and the ability to compete to beat Lee Sedol at Go, again, I think this is a team of about 25 people working over the period of about 3 years, and introducing this new concept of reinforcement learning. If you look at Jeopardy Watson, what's interesting about Jeopardy Watson is that it learned to beat humans by being trained off of only 25,000 questions, which sounds like a potentially large number of questions for training data. But the reality is, if you look at the earlier version of DeepMind, DeepMind relied on 300,000 expert moves, expert examples of gameplay, and then eventually evolved to this reinforcement learning model that was able to win at Go with only 3 days of self-play. So this is similar to the types of problems that my team is trying to solve. So this is the system architecture for Uber. So Uber announced and has a very extensive blog post around Michelangelo. So Uber created, there are no tools, as I was saying. There are no tools out of the box that companies can use in order to do artificial intelligence nowadays. They need to build a lot of these tools themselves. And in order to build the system that Uber uses to make sure that your driver gets to you on at the right time, and they can estimate how long it's going to take you to get to your destination, it requires a very significant machine and deep learning, data science-driven architecture, and this is a reason that we need AI architects. We need people that understand systems at this level. So systems where you've got data on one side, you are extracting the data, building out your feature stores, tracking your training data sets, tracking your sampled predictions, making predictions at scale, capturing and training models, hosting models, capturing data as it comes from the endpoints, from people's phones, and then tracking that data back into the master data repository, and then using that data for continuous learning so that you can train new data sets and continually improve your systems. Sorry, just checking time. So let me just end here with what we're doing at IBM Watson. So we're working to build the tools that data scientists can use in order to conduct machine and deep learning at scale. So the ability to run thousands of experiments, hundreds of thousands, training hundreds of thousands of neural networks, accessing the power of GPU acceleration. And the way that we do this is through a Kubernetes-based approach, where we're able to take your data, take your training sets, take your machine learning models, distribute them across a cluster of GPU accelerated hardware, bring in your training data, and do this at scale. So allow users to submit a large number of training runs and be able to execute all those simultaneously. So I'll skip over this, but this is the architecture that our team is working on, and time's a little bit short. So let me just stop there, and we could talk a little bit more after the next couple of keynotes. There's a coffee break session where all the keynote speakers will be available to talk.